Venus is often called the most extreme planet in the solar system, and for good reason. Crushing surface pressure, scorching temperatures, and clouds made of sulfuric acid make it one of the most difficult planets to explore. Back in the early 1960s, humanity knew very little about Venus, apart from the fact that it was similar in size and mass to Earth, and that its surface was always hidden beneath a thick layer of clouds. Speculations ran wild. Some imagined a world locked in eternal ice, while others pictured an ocean of oil covering the planet. Sci-fi writers of that time had their own version of Venus, a prehistoric Earth filled with swamps and dinosaurs. So it's no surprise that Venus, not Mars, was the main target of early interplanetary missions. The Soviet Union made the first attempt to send a probe to Venus in February 1961. It failed. The spacecraft never left Earth's orbit and re-entered the atmosphere shortly after launch. Ironically, its remains fell back on Soviet territory. Among them was a small titanium sphere containing a commemorative medal. It was later recovered and returned to OKB-1. One can only imagine what the engineers felt when they saw this strange souvenir that was supposed to go to another planet. Space technology back then was raw. Every bit of experience came through trial and error. Between 1961 and 1965, the USSR made 11 attempts to send probes to Venus. Only 3 made it beyond Earth's gravity: Venera 1, Venera 2, and Venera 3. Unfortunately, all 3 lost contact before sending any data back. Calculations later showed that Venera 3 likely entered Venus's atmosphere and is considered the first human-made object to reach another planet's surface. Despite limited success, these missions weren't in vain. They paved the way for the next generation of more advanced interplanetary explorers. By 1967, humanity had learned a bit more about Venus. And the news wasn't great, especially for those hoping it might be habitable. All data pointed to a surface far too hot, with an incredibly dense atmosphere. The dream of a wild, unexplored paradise was dead. But there was only one way to be sure: send a lander into Venus's atmosphere and take direct measurements. That's where the 3MV missions came in. Interestingly, at the time, Soviet engineers still had hope there might be oceans on Venus. The landers were even designed to float, just in case. One of these spacecraft, later named Venera 4, managed to reach Venus. On October 18, 1967, its lander entered the atmosphere. Optimistic estimates suggested surface pressure might be around 10 Earth atmospheres, with temperatures near 270 degrees Celsius, and an atmosphere mostly made of nitrogen. So the probe was built to handle up to 20 atmospheres, just in case. Venera 4 stopped transmitting when the temperature outside hit 262 degrees Celsius and pressure reached 18 atmospheres. Later analysis showed that it was still 28 kilometers above the surface when it failed. The data revealed something stunning. The atmosphere was over 90% carbon dioxide. This meant the actual pressure and temperature on the surface were even worse than expected. Venera 5 and Venera 6 met the same fate. Their landers were destroyed by Venus's brutal atmosphere before reaching the ground, but they still confirmed Venera 4's findings. The issue wasn't technical flawed. The landers were built before scientists knew what Venus was really like. Venera 7 faced technical problems too. A switch failed, and only temperature data was transmitted. Then the parachute tore off. Still, the probe survived the fall and sent a weak signal from the surface for 23 minutes. It revealed surface temperatures of 457 to 474 degrees Celsius and pressure around 90 plus or minus 15 atmospheres. 2 years later, Venera 8 confirmed the extreme surface conditions, with pressure equal to that found 900 meters deep in Earth's oceans. It also measured lighting conditions, which turned out to be similar to an overcast day on Earth. Good enough for photography. Enter Venera 9 and Venera 10. Their job: capture the first photos from Venus's surface. This was no small task. Engineers had to keep the cameras cool inside a sealed compartment. But how to take pictures then? The solution: a window and a periscope-like device with scanning mirrors. There were doubts, though. Some believed that because of extreme atmospheric refraction, a camera on Venus might see distorted horizons or even photograph itself. Others thought a thick fog would obscure everything. In October 1975, both landers succeeded. The myths were debunked. Photography on Venus was possible. The photos from Venera 9 showed a rocky landscape with sharp-edged stones. In contrast, Venera 10 landed in a smoother area with flat slabs, likely ancient lava flows. No dust or haze was found in the atmosphere, and lighting was better than expected. Onboard lights weren't even needed. Next step: color images. That was the goal of Venera 11 and Venera 12, launched in 1978.
4 месяца.
Sadly, they didn't deliver. Protective lens caps failed to eject, and the landers took no panoramas. A soil analysis experiment also failed. It was disappointing, but it pushed engineers to improve. That improvement came with Venera 13 and Venera 14. After countless tests and redesigns, these missions succeeded. In October and November 1982, they transmitted the first, and still the only, color images from Venus's surface. They also analyzed the soil and even recorded the ambient sounds of the planet, giving us not just a picture, but a deeper sensory glimpse into one of the most extreme places in the solar system. What is happening with Venus missions in 2025? For decades, Venus was largely ignored. After the Soviet Vega landers in the 1980s, no spacecraft touched its surface again. While Mars became the darling of space agencies and private companies, Venus seemed to fade into the background. Too hot, too hostile, too hard. But in recent years, something changed. A quiet renaissance has begun. And in 2025, interest in the second planet from the Sun is rising again. What caused this renewed attention? It started with an unexpected scientific controversy. In 2020, a group of researchers claimed to have detected phosphine in Venus's upper atmosphere, a gas that, on Earth, is associated with microbial life. The findings were debated, reanalyzed, and questioned, but they had already done their job. They reignited humanity's curiosity. Since then, multiple missions to Venus have been proposed, approved, and scheduled. And for the first time in decades, we are no longer speaking of a single probe, but of a new wave of explorers. NASA has committed to 2 ambitious missions. The first is Da Vinci, short for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging. Scheduled to launch in the late 2020s, Da Vinci will drop a descent probe through Venus's thick atmosphere. It will collect detailed data on gases, temperature, pressure, and chemistry as it plunges to the surface. The goal: to understand the planet's origin, its evolution, and whether it ever had oceans. The second NASA mission is Veritas, Venus Emissivity, Radioscience, INSAR, Topography, and Spectroscopy. While Da Vinci dives down, Veritas will orbit. It will map the planet's surface in unprecedented detail, using radar and spectroscopy to pierce the clouds and reveal the geology beneath. With resolutions 100 times better than previous missions, Veritas may uncover evidence of ancient tectonics, past volcanoes, or even active ones. But NASA is not alone. The European Space Agency has its own mission, Envision, scheduled to launch in the early 2030s. Like Veritas, Envision will orbit Venus and study its surface and atmosphere using radar and spectrometers. Together, these missions will offer overlapping data sets and a chance to cross-verify findings from different sensors and angles. Meanwhile, India is preparing its first dedicated Venus mission, Chakrayan-1. Organized by ISRO, the Indian Space Research Organization, this spacecraft will carry an orbiter to study Venus's atmosphere and cloud layers. Though the mission has faced delays, it may launch before the decade is out. And what about private companies? While no major Venus landers have yet been developed commercially, interest is growing. NASA has invited private contractors to propose concepts for future missions. One bold idea: reusable balloon platforms that could float through Venus's upper clouds for weeks or months, relaying data without being destroyed by the surface heat. Another intriguing project is Rocket Lab's Photon Venus mission, a small private probe designed to study Venus's atmosphere at a fraction of the cost of traditional programs. Though limited in scope, it could pave the way for affordable, rapid exploration of the inner planets. In the coming years, humanity will return to Venus not with a single nation's banner, but with a constellation of robotic explorers. Orbiters, descent probes, spectrometers, and balloons will try to answer the planet's ancient riddles. Why did Venus become a hell world, and could it have been Earth-like once? Could it ever be again? In 2025, Venus is no longer forgotten. It is rising again, not just in the morning sky, but in our scientific imagination.